This is transformations of quadratics. For those of you that don't know, a quadratic is any equation that has to do with squares. Not like the shape, but rather like exponents. So the most basic quadratic, and the one that we're going to be using as a parent function in this video, is y equals x squared. The three types of transformations that you can do to a quadratic are translations, dilations, and reflections. Translations are moving the quadratic, dilations are stretching the quadratic, and reflections are reflecting the quadratic. Alright, first thing we're doing is translations. Translation is moving the quadratic. So we have graphed out here two kinds of translations as well as our parent function. Our parent function is y equals x squared, and that's graphed out with the black line that starts at 0, 0. The first translation we'll be doing is translating it along the x. The x translation is in blue. So when you translate it along the x, what you're going to be doing is you're going to be moving your quadratic along the x-axis. The most basic one we have out here moves it one to the right. However, because x translations are a little bit odd, in our equation we have y equals x minus 1 rather than plus 1. That's just how it works. Anyway, so that one moves it just one over here, but it doesn't alter the shape or the curve of the quadratic at all. And the second one we have graphed out here is translating it along the y, where we've translated it simply up 3. So again, the curve is the exact same. It's just the starting point is higher. That's essentially what translations are, just moving the starting point around. So for this, we have y equals x squared plus 3, and that simply moves the starting point up 3 along the x-axis. Translations, like the x and the y translations, can be used together, and you can move your parabola or your quadratic pretty much anywhere around the graph. Alright, our next transformation is reflections. Alright, so we have, reflections is exactly what it sounds like. It's reflecting the starting quadratic, which we have right here in black again, across either the x or the y-axis, or even both. So instead of using our parent function for our starting quadratic, we decided to use a different one so it'd be easier to see the reflections across the y-axis. So our starting one has the starting point at 1, 1, just so that you can see easier which ones the reflections are. So the first reflection is reflecting across the y-axis. To reflect across the y-axis, you simply need to make the x negative. So in our equation down here with the dotted line, it's y equals, in parentheses, negative x minus 1 squared plus 1. So it's that negative before the x that turns this, that makes our starting equation go from here to over here. The second one is reflecting across the x-axis, which you have to make the entire equation negative. So you just put the whole equation in parentheses and a negative before it, and that'll flip your entire starting quadratic over the over the x. Right, so our final transformation is dilations, which is stretching the quadratic. So just a quick change, our parent function, or our parent quadratic this time, is the dotted line rather than the black line. The black line is our vertically dilated quadratic. So in our vertically dilated quadratic, what we simply do is we multiply the x by 2. So while our just normal parent function goes up 1 over 1, but then it's going to go up 1 over 3, our vertically dilated quadratic, which we have dilated by 2, you can dilate it by other numbers, but ours is dilated by 2, it goes up over 1, up 2, over 1, up 6, and so it just doubles the amount that you go up for each individual step. We also have a horizontally dilated quadratic, which simply does the opposite, where we have the x divided by 2 right here. So that's our blue line. And sort of like the other one, but just opposite, is rather than going up 1 over 1 and then like over 1 up 3, we go over 2 up 1 and then over 2 up 3. So it's simply just multiplying either however many you choose out, and so you can stretch your quadratics wider, or you can make them thinner by vertically or horizontally dilating. So just again, horizontal dilations make the parabola wider from your parent function, and then vertical dilations make your parabola thinner.